In question number 16, it says convert these recurring decimals to fractions. So here we will apply a different strategy to convert these decimals into fractions. Like it's not that much simple. Like in previous questions, let's suppose we were dealing with such question where, let's suppose it was 0.7, then we were just writing 7/10. But here 7 is recurring, so that's why we will apply a different strategy, means we will take help of an algebraic techniques. So let me do A part first of question number 16, where we have 0.7 and 7 is the recurring number. Like in other words, we can also write it as 0.7777 and up to so on. So let me assume this number as x. So if I suppose that this number is equals to x, like 0.7777 and up to so on, and if I multiply both sides by 10, I get 10x equals 0.777 and up to so on times 10. Means I will get 10x equals 7.7. Like by multiplying with a number that is power of. In question number 16, it says convert these recurring decimals to fractions. So first of all, I will do A part. In A part, we have to convert this recurring decimal into fraction. So it's a bit different from other questions because here the decimals or the digits after the decimal point is being repeated. So here 7 is being repeated. So first we can suppose this number that it is equals to x, and in this number 7 is the digit which is being repeated. So this is how we can write it. So now we'll apply a bit algebraic technique here, that first we will multiply both sides by 10. So if we multiply both sides by 10, we get 10x on the left side, and on the right side we get 7.777 and up to so on. You can clearly see that if we call it equation 1 and this one as equation 2, if we subtract equation 1 from equation 2, the whole decimal part can be subtracted from the decimal part of equation 2. So let's do this subtraction. If we subtract the left side of equation 1 from equation 2, we get 9x, and if we subtract the right side, we get 7 on the right, and our answer will be equals to 7 divided by 9, because if we divide both sides by 9, we get 7/9. Now I will do C part, where we have 0.15 and 15 is being repeated. So first we can suppose it that x equals to 0.151515, and 15 is being repeated. So look that we have to multiply with such number that it becomes easy to subtract the whole decimal part of this equation 1 from the another equation. So this time 2 digits are being repeated, like 15. So we will multiply both sides by 100. And if we multiply both sides by 100, we get 100x on the left side and 15.151515. And you can see that this decimal part of equation 1 can be subtracted from equation number 2. So if we subtract equation 1 from equation 2, we get 99x on the left side and 15 on the right side. And now it's very easy to further simplify it, because if we divide both sides by 99, we get 15/99. And if we divide with the highest common factor, which is 3, we get 5/33. Now I will do E part. In E part, we are given with 0.123, where all these 3 digits are being repeated. So first we will suppose it that x equals to 0.123123 and up to so on. This time, to get subtracted the whole decimal part of equation 1 from another equation, we will need to multiply this by 1000, because 1000 will shift the decimal point 3 digits forward, and we will get the same repeated recurring decimal part in equation 2 as it is in equation 1. So we will get 1000x on the left side, and on the right side we will get 123.123, and 123. So now the whole decimal part can be easily subtracted, because if you see on the equation number 2 and equation number 1, you can compare that we have the same decimal part as we have in equation 1, because here 1, 2, 3 are the recurring digits, and similarly in equation 2 we have 1, 2, 3 as the recurring digits. So if we subtract equation 1 from equation 2, we get 999x on the left side and 123 on the right side. And we can further simplify by dividing both sides by 999. The highest common factor of both these numbers is 3. So if we divide it, we get 41 over 333 as the simplest form of the answer. Now we will do G part. In G part, we are given with 0.03 and 3 is being repeated. So please remember that, first of all, actually, we need to suppose it that x equals to 0.0333. So in these types of questions, please remember that first try to bring the decimal point just before the non-zero digit. So to bring it just before to non-zero digit, we need to multiply both sides by 10. We get 10x on the left side, and on the right side, we get 0.333 and up to so on. Now we can see that this decimal part, which is 0.3333, cannot be subtracted from 333 and up to so on because both decimal parts are not same. So that's why we will multiply this equation, means equation number 2. This was equation number 1. We will multiply equation 2 with 10 again. So if we multiply that equation with 10 again, we get 100x on the left side, and on the right side, we will get 3.3333 and up to so on. Now you can see that we can easily subtract this decimal part, 0. Which is actually 333 from this decimal part. So we will get, if we subtract equation 2 from equation 3, we get 90x on the left side and 3 on the right side. So in its simplest form, we will get 3 over 90. And if we divide both sides, both numerators and denominator by 3, we get 1 over 30. Now I will do H part. In H part, we are given with 0.15, where 5 is being repeated. So I will first of all suppose the number that it is equals to x, and 5 is the digit which is being repeated. So I will repeat 5 and up to so on, and we will call it equation 1. Now you can see that first, if we multiply the number by 10, I will get 10x on the left side, and I will get 1.555 and up to so on the right side. But still, we can't get subtracted the whole decimal part from this decimal part because these decimal parts are not same. So to make that same, we will further multiply that number by 10. We get 100x on the left side, and on the right side, we will get 15.5555 and to so on. Now we can easily subtract the decimal part of equation 2 from equation 3. So we will get 90x on the left side and 14 on the right side. And we can divide both sides by 90 to further simplify. So if we divide both numerators and denominator by 2, we get 7 over 45. Now I will do I part. In I part, we have 0.027, where 7 is being repeated. So first of all, I will say x equals to 0.02777 and up to so on. And as I have described before, that first try to bring the decimal point just before the non-zero digit here. So we will multiply both sides by 10, and we get 10x on the left side, and we get 0.2777 on the right side. But still, we can't get subtracted the whole decimal part of above equation 1 from equation 2 because decimal parts are not same. So we will multiply again by 10. We get 100x on the left side, and on the right side, we will get 2.777. But still, the decimal parts are not same. So we can't get subtracted the decimal part of equation 2 from equation 3. So let's multiply again by 10. So we get 1000x on the left side, and on the right side, we will get 27.777. Now we can easily subtract equation 3 from equation 4, and we will get the decimal parts subtracted. So on the left side, we will get 900, and on the right side, we will get 25. If we divide both sides by 900, we get 25 over 900. And if we divide both sides by the highest common factor, which is 25, we get 1 over 36. Now I will do J part. In J part, we have 0.063, where 63 is being repeated. So first of all, let's assume that x equals to 0.0636363 and call it equation 1. So we'll try to bring the decimal after just before non-zero digits. So we will get 10x on the left side, and on the right side, we will get 0.6363 and 63. Now to make sure that the whole decimal part can be subtracted from another equation, we will multiply the both sides by 100. So if we multiply both sides by 100, we get 1000x on the left side, and on the right side we will get 63.636363. Now we can easily subtract the whole decimal part of equation 2 from equation 3. If we subtract, we get 990 on the left side, and on the right side we get 63. If we divide both sides by 990, we get 63 divided by 990. And if we divide by the highest common factor, which is 9, we get 7 over 110. Now I will do K part. In K part, we are given with 0.245, where 45 is being repeated. So let's suppose that x equals to 0.2454545. Call it equation 1. And as 45 is being repeated, so let's bring the decimal point just before 4, the repeated numbers. So we will multiply both sides by 10. We get 10x, and on the right side we get 2.454545. We will just call it equation 2. And now we will multiply again by 100, because if we multiply both sides by 100, on the right side we can get the same decimal parts in both equations. Like if we multiply by 100, we get 1000x on the left side, and on the right side we will get 245.454545, and call it equation number 3. We can subtract equation 2 from equation 3, we get 990x, and on the right side we get 243. And if we divide both sides by 990, we can divide by the highest common factor, which is 9. So on the top we get 27, and on the bottom we get 110. So please remember that in all questions, first of all, try to bring the decimal point just before the repeated numbers. Like here 45 was being repeated, so we brought this decimal point just before 4 by multiplying with 10. And then you need to just observe the digits, and you need to observe the decimals. Like here 45 was being repeated, so we multiplied both sides by 100 because it was making the same decimal parts in both equations, like in equation 2 and equation 3. And then you can further subtract to get your answer. You basically need to subtract the left sides, so you got 990, and if you subtract the right sides, you got 243. Now we will do L part. In part L, we are given with 0.1407, and 407 is being repeated. So first, suppose that this is equals to x, and we have 0.1407, 407, 407, and 407 is being repeated, and call it equation 1. Now multiply both sides by 10, because first try to bring the decimal just before the repeated numbers. So we'll multiply both sides by 10, we get 10x on the left side, and on the right side we will get 1.407, 407, 407. Call it equation number 2. Now again, we need to multiply with a number so that we get the same decimal part in both equations. Like in equation 1 and 2, we don't have same decimal parts. So now we have to multiply with 1000, because we have 3 digits which are being repeated. So let's multiply by 1000. We get 10,000 on the left side. We get 10,000x on the left side, and we get 1,407.407, 407, 407 on the right side. Now if we subtract equation 2 from equation 3, we get 9,990 on the left side, and on the right side we get 1,406. And now if we divide both sides by 9,990, we get x equals to 1406 divided by 9,990. Now by using calculator, if we further simplify, we get 19 over 135. So this is the simplest form of the answer. Let's do question number 17. In question number 17, part A, we are given with 33.3%, and here 3 is the recurring decimal. So first of all, we know that instead of putting symbol, we can divide the number by 100 to convert into fraction. So we can convert like this, that 33.3 and dot notation, and then divide it by 100. To further solve, we will need to convert this decimal, recurring decimal, into fraction. So we know how to convert. So first of all, we will do it separately, that 33.3 and we will suppose that it's equals to x, and we can also rewrite it as 33.333, and this 3 is being repeated. Now if we multiply both sides by 10, we get 10x on the left side, and on the right side we get 333.333. If we subtract, if we call it equation 1 and equation 2, and if we subtract equation 1 from equation 2, we get 9x on the left side, and on the right side we get 300. So if we further simplify, we get x equals to 300 divided by 9. And if we divide by the highest common factor, which is 3, we get 100 divided by 3. So it means that we can replace this 33.3, where we have 3 as the recurring decimal, we can replace with 100 divided by 3. And as we know that it is being further divided by 100 because of the percentage, so we can represent this number as divided by 100 in this form. Now to further solve it, we can apply the rule like keep, change, flip. So it's 100 divided by 3 times 1 over 100. And if we cancel these both numbers like 100 and 100, we get 1/3 as our simplest form. So this is the answer. So in all questions, I would recommend that you first need to convert the recurring decimal into fraction and then divide by 100 because of the percentage symbol. Like in B part, if we do it, first of all, it's 1.1 and it's a recurring decimal, and also we have percentage symbol. So first of all, we will do the decimal part, like we will suppose that this portion is equivalent to x, that 1.1, and 1 is being repeated. So we can also write in this form that 1, 1, 1, because 1 is being repeated. And if we multiply both sides by 10, we get 10x on the left side, and we get 11.111 on the right side. And now if we subtract equation 1 from equation 2, we get 9x on the left side and 10 on the right side. And further, if we solve, we get 10 divided by 9. But as we know that this number, like if we replace 1.1, like if we further solve it, we can replace 1.1 with 10 divided by 9, and the percentage symbol can be replaced with divided by 100. So now if we do keep, change, flip, we can write 10 divided by 9 times 1 over 100. And if we further simplify, we get 10 over 900. And further simplify, we get 1 over 90. So this is the final simplest form. So in all remaining parts, you can first convert the recurring decimal into fraction and then divide by 100 to convert the percentages into fractions. So please apply the same rule as we applied in question number 16 to convert recurring decimals into fractions and then divide by 100 in this form. I'm leaving remaining parts for your practice. Let's do question number 18, where we have to convert this number into fraction. If we rewrite, it is actually, if I suppose that it is equals to x, like x equals to 0.01234567, and again the number is being repeated, so I will write 0.1234579 and up to so on. Now I need to multiply with a number which is a power of 10 and it has 9 zeros. So I will multiply with 10 raised to power 9 because it will shift my decimal point just after 9 over there. So if I multiply both sides by 10 raised to power 9 means 1000 million. I get 1000 million on the left side, 1000 million x basically. And on the right side, I will get 1234567.01234567. And this number is being repeated, so I will put dots. Now if I subtract equation 1 from equation number 2, I get 999,999,999x equals 1234567.9. Now if I divide both sides by this number, which is actually 999,999,999, we get our answer in the simplest form as 1 over 81. So if we use the calculator, we can easily solve it. Now we will do question number 19, and it's A part. It says which one is the largest, 45% or 4 9s? So we can convert both numbers into decimal if we use the calculator, and if we divide 45 by 100, it will be 0.45, and if we divide 4 upon 9, it will be 0.444, and up to so on, where 4 is being repeated number. So 45 or 0.45 or 45 hundredths is more than 0.444. Even 4 is the recurring digit, but still 0.45 is greater. So that's why we will say that we'll just circle 45% that it is greater. Similarly, in B part, we have to figure out which one is greater. So we can first divide 1 upon 6. We get 0.16666, where 6 is being repeated. So, and we also have one more number, which is 1.6%, where 6 is actually being repeated. So we can also write it as 1.6666 and up to so on. And if we also divide it by 100 because of the percentage symbol, we get 0.016666, where 6 is being repeated. So definitely 1/6 is more than that. So we will circle 1/6. Also, if we use calculator to convert 10 over 81 into decimal, we will get 0.123456791 and up to so on. So definitely this number is the recurring decimal, so this one is greater. I'm leaving this last part for you for your practice. You can try, and also you can ask questions through comments. Thank you.